at 9. There's the Cowboy Lounge Friday at 5:30. There's the Cowboy 5K Gallop and Trot on Saturday morning, and many more events going around around campus this week. But today we will be listening to HU Talk with Dr. Jennifer Lindline, Water After Wildfires, 1 year post 2022 Hermits Peak Cap Canyon Fire. Give her a warm welcome, everyone. Thank you.
Thanks, guys. Thank you, Julie, and the New Mexico Highlands University Foundation for inviting me to speak or being part of the homecoming celebration. My pleasure to share work that my students and I have been doing over the past year, and particularly engagement by the environmental geology program is helping to build skills and move us forward in improving lives and livelihoods. So I know a lot of folks on screen and in the room, so let me first share a little bit about who I am. So a lot of you guys know me as Jennifer Lindline, geology professor extraordinaire. Just kidding. I'm a wife. I've been married to this guy, Bill Schneider, for 26 years. And I'm also a mother to these two beautiful daughters, Tara's 17 and Francis is 20. They have all been part of my at New Mexico Highlands University, starting my 24th year as a professor of this rowdy bunch. I've got tons of pictures of students throughout the years, all of whom uplift me. And at the base of all of this, I'm a cowgirl. But yeah, so the Hermits Peak Cap Canyon Fire of 2022 was the largest and most destructive wildfire in New Mexico's history. It transformed the biotic and sociocultural environments, and it disrupted many of the special places that all of us know and love. This is the place where I've raised my daughters. This is the place where they have come to know the wonder and its sacredness. This is the place where we have celebrated birthdays and reveled in milestones. This is a picture of my first coming to New Mexico Highlands University, first week in January of 2020. Everybody said we had to make it up Hermits Peak, and by gosh, we did. We've been up there bunches of them. But like I said, I'm also a geology professor. This is my students and I. We map the geology. We sample the rocks. We look at all of the outcomes to understand the stories that they share or the information that they reveal. And by golly, have we enjoyed the view from the top. This upper one here is from a couple of years ago at the top of Elk Mountain. And of course, this is from Hermits Peak. So this is a picture that I took while in our natural laboratory with Andrew Romero, who is now with the New Mexico Environment Department. This was Labor Day weekend in 2013. We were buttoning up some things in his master's thesis project, and this was our view. From the same point last Wednesday, this is the view today. This is a picture that I took with Joe Zabrowski, as he and I were preparing for a big conference back in 2015, looking southeast along the Guyanas watershed from Johnson Mesa. And this is the picture from last Wednesday. So the Hermits Peak Cap Canyon Fire burned more than 340,000 acres, and from the information incident map that I superimpose on this other one, we can see how the fire burned in a variety of severities, from very low to low, moderate, and high. And each of these categories, as they are first estimated and then ground truth, tell us something about the degree of soil intactedness versus its susceptibility to erosion. The lower the burn severity, the more intact those soils are. The more they are still able to absorb water, infiltrate, and retain their character. The higher the burn severity, the less that capacity for infiltration or anchoring the ground cover. This is the map that was created by folks at the New Mexico Forest and Watershed Restoration Institute that outlines the different watersheds within our state. I superimposed on it the Hermits Peak Canyon footprint. As you can see, the fire reached portions of the upper Rio Grande, the upper Canadian, and the upper Pecos watersheds, as well as their many sub-watersheds. In the upper Pecos watershed, the headwaters of all the tributaries on its eastern side were within the wildfire perimeter, including Rio Mata, headwaters Cow Creek, Bull Creek, Apache Creek, and Manzanares Creek. In the Gallinas watershed, the headwaters Gallinas Creek, Tecolote Creek, Burrow Creek, Beaver Creek, Pollinger, and Porvenir were impacted. Now, depending on where within a river's network a forest fire has burned, it can have various impacts. If it burns in the low waters, it often impacts drinking water supplies. When it occurs in the mid-waters area, it impacts the fishing, agricultural, and recreation sports. When it burns in the headwaters, it impacts or it has watershed scale disturbances. And whether all or parts of a region has experienced these types of burns, there's going to be some degree of tree mortality, charred debris, soil burns, and bare grounds that are all going to impact the watersheds. So in the upper left-hand picture where you see the grays and the whites, that's indicating high burn severity when you have those loose ashes and those granular material. That soil layer is no longer intact and is highly susceptible to erosion. As the hillsides are destabilized, small and large materials can get into the streams, get into the tributaries and into the watersheds, contributing to debris flows. And with the lessening of infiltration, you're going to have more surface water runoff and higher peak flows and a shorter lag time between precipitation events and peak runoff, creating and exacerbating floods. All of this happened last summer in response to the Hermits Peak Canyon fire. So today I'm going to talk specifically about two of our beloved watersheds, the Upper Pecos watershed and the Gallinas watershed, both impacted by the fire. Both are sub-watersheds of the Pecos watershed. They both start up in the Sangre de Cristo Mountains in high elevations greater than 10,000 feet in our forested terrains and run for many, many miles as they enter into the Great Plains areas. Both include forest, rangeland, farmland, and dispersed residential uses. Both sustain our greater than 500-year traditions of Hispanic acequia systems. Both are designated as high-quality cold water fisheries. Both maintain diverse ecological values and support rich traditions of farming, ranching, and other long-standing use, all of which depend on clean water. Both are among New Mexico's most outstanding aquatic resources, supporting people, plants, and wildlife alike. Both have been listed in the past couple of years as some of America's most endangered. The Headwaters Pecos watershed had about 40,000 acres that were burned, a third of which classified as high severity burn. The Upper Gallinas had about 100,000 acres that were burned, a fifth of which were identified as high burn severity. All of which susceptible to flood, erosion, and those other things that I mentioned, but what makes the Pecos ever so much more pronounced is it is home to the Pecos strain of the endangered Rio Grande cutthroat trout that depends on clear water with sufficient dissolved oxygen. The Guides supports the city of Las Vegas and its 13,000 plus residents as its primary drinking water supply. So, water quality monitoring. Water quality is a measure of the health of a stream. It provides environmental scientists with an indication of the physical chemical parameters that support its various uses, and it provides empirical information for water managers, decision makers, and restoration specialists about environmental issues and areas of concern. My students and I have been monitoring sites along the Upper Pecos since the winter of 2020. So we were doing that for a year and a half on a bi-weekly basis, using an in-the-field instrument, a sonde, to gather these parameters. So I'll share some of the data from those studies with you today, as well as data that we've been able to capture in the last couple of summers. Two of those students are here, Letitia and Megan, fantastic. But, so we were looking at turbidity. Turbidity is a measure of the clarity of a stream, how much suspended solids are in it. And like I said, aquatic organisms want clarified streams. So, and the threshold for high quality cold water is 10 NTUs. So over that year and a half, when Megan and Letitia were measuring these values, for little to rarely to never did the Upper Pecos exceed that 10 NTU. They did a couple times in the summer of 21 during storm events or high runoff events. Contrast that with last summer. We were only able to get to a couple of sites, and our number of times at those sites were diminished because the fire was happening and many of those sites were closed off. Nonetheless, as we were out there, you can still see that line that shows the quality threshold. During our time of measuring, there were multiple times that the Upper Pecos River exceeded that 10 NTU value by many, many more times. This summer, Mary Frances Bibb, one of our environmental geology students, graduated in May from graduate school. She's been going out on a bi-weekly basis as well. Look at the data from this summer. There was only one outing where the river exceeded those values, and it was nothing like last summer's value. For the majority of the summer, the water quality remained within its threshold in terms of turbidity. Let's look at dissolved oxygen. Dissolved oxygen, the amount of oxygen dissolved to support aquatic life. During Megan and Letitia's year and a half study, you want dissolved oxygen to be at or above 6 milligrams per liter. And for the majority of that time, the Pecos did have that. Contrast that with last summer. Much of the time, the Upper Pecos was less than 6 milligrams per liter in terms of dissolved oxygen.
It drops down because
it often drops down when the water is hot. Temperature has to do with that, and suspended solids. Now look at this summer, using the same instrument, the same calibrations, the water has been within its dissolved oxygen needs. Let's look to it, electrical conductivity. That's a measure of how well a water body conducts a charge, and that has to do with the numbers of total dissolved chemicals or ions within that. It doesn't tell you specifically what ions, just a measure of total dissolved ions. So you don't want it for a cold water designation for it to exceed 300 microsieverts per centimeter. And during Megan and Letitia's time of study, it did not. And last summer, it didn't either. The Upper Pecos River maintained a low electrical conductivity. And it did so as well this summer. Let's look now at an instrumentation that was in place within the Guyanus River upstream of the city of Las Vegas diversion. There's a picture of it here. And here they put in an instrument that's automatically measuring these various parameters every 15 minutes of every hour of every day. So a vast database. They deployed this instrument after containment of the fire last summer. So while we don't have historical data, we do have data post-containment. So these two graphs are showing turbidity at the top and dissolved oxygen at the bottom. These are data that I pulled off of the USGS's website. I also kept in there those lines showing the 10 NTUs for turbidity and the 6 micrograms per liter thresholds for high quality standards. Look at from August 13th, or this was just for the end summer last year, that turbidity was high. Dissolved oxygen though remained within its high quality threshold. Let's look now at this summer. The bottom axis is showing time, so I grabbed now just June to August of 2023. Again, turbidity at the top and dissolved oxygen at the bottom. So just this summer, above the city's diversion, notice how many times turbidity was not only above the 10 NTUs, but very high above. We're looking at a scale, you know, tens and tens, like exponentially higher than that threshold. And now I point out to you for the whole entirety of the data collection from last August to today. Just again, seeing that the river often responds in a negative way to high amounts of runoff or high amounts of ash and suspended particles due to its post-Hermits peak. I also grabbed a couple other parameters. At the top is specific conductance, and at the bottom is temperature, still on the Guyanus River. So over to the right, we're looking at that electrical conductivity. And the Guyanus River still remains less than 300 in terms of its specific conductivity values. And majoritively, temperature has remained low, less than 20 degrees Celsius or 68 degrees Fahrenheit. You do notice in terms of temperature, there are days in the summer, but that's not unusual for the Guyanus. We do find that when discharge is low and air temperature is high, water temperature increases as well. And it's something that has been noted by the New Mexico Environment Department and many of the stakeholders. It's something folks will keep in track.
They didn't collect through the winter.
What'd you say?
The data was not collected through the winter.
Thank you for asking that, David. There was a problem with the instrument. They thought it was collecting, and it actually was one of our students that brought to their attention. Hey, she's doing a master's thesis with this data, and I'm like, dang, man, there's a gap here. But yeah, something, there was a problem. Sometimes the problem is it can freeze over when in times of really low flow. Now, in terms of pH, oftentimes people ask me about pH of the river. So over on the left are data that the students were gathering. Again, oh, I forgot to have the labels with it. The upper graph is that summer 20 and 21, the middle 22, and the last 23. pH is really variable. We calibrate that instrument before we go in the field, while we're in the field, and these are what the data are showing. Now for pH, you want the river's pH to be between 6.6 and 8.4 for its high quality cold water designation. And as you can see in this image, pH is really variable in the Pecos River. Megan ran some statistics and tried to look and see if and how much it correlates with discharge. And there's a low to modest correlation with discharge, but it's definitely not a perfect correlation. Last summer, the pH wasn't as variable, but it did remain low, lower than that 6.6. And this summer as well, little bit higher, but not exactly where we want it to be. Over on the right are the data being collected by the USGS. And I couldn't change the vertical axis to be the same as to the left, but you'll see that most of the pH is within the 6.6 to 8.4. It too has a few times where it shoots off above, but it's not below. Now you might ask why. My husband asked why yesterday when he was looking over my shoulders and I was practicing my presentation. And I know a lot of the variability in pH has to do with the geology. What is the natural pH of the rocks and the soils? And in the Pecos hosts near Willow Creek, Proterozoic, volcanogenic, massive sulfide deposit. It was long mined in the late 1800s and the early 1900s for the copper, lead, and zinc that it bears. Since the late 1990s and 2000, the area has been reclamated. The waste rock piles have been capped and sealed. Much of the water is being treated on site or conveyed and worked upon. But nevertheless, that geology is there. There are natural times of stream flow where you're going to be putting some of these sulfides that are naturally occurring into the water and disrupting the pH. Those kinds of deposits don't exist on the east side of the Sangres, on the Pecos side of the divide, or on the Guyanus side of the divide. Rather, the Guyanus watershed is capped by thick units of the Paleozoic Madera Formation that actually add to or carbonates or kind of buffer the system. So those relatively high pHs as we're getting into that alkaline zone are likely due to the rocks and the soils that are eroding from and mixing with those waters. Macroinvertebrates are also indicators of water quality. Macro, visible, invertebrates, those little critters with a backbone. And some species have a low tolerance, like stonefly nymphs, that even small amounts of chemicals or changes in water quality can be detrimental to those. Others have moderate tolerance, like mayfly nymphs, caddisfly larvae, dragonflies, and ripple beetle larvae, and others have high tolerance, like worms and midges and stuff. So looking at what macroinvertebrates are nurturing, the species numbers and the species diversity can tell you something about water quality. The more you have those critters of a moderate and low tolerance, it's telling you there's a good health. The less of those, the more they have a high tolerance, that's telling you there could be some disequilibrium within your system. Last year, with the help of Dr. Sebastian Medina in the biology department, we embarked on a study of the bioindicators of stream health within the Pecos and the Guyanus. We were looking at post-fire containment, and we sampled for 6 weeks at an upper and lower site in the Pecos and an upper and lower site in the Guyanus for comparison. And these were our results. Both had critters, both had bugs, and Kenneth worked hard and diligently to separate the macroinvertebrates in each sample, identify and catalog those. You can see maybe not all of the writing on the slides, but just by the axes themselves. Over on the Pecos side, there was much more species numbers and species richness. On the Guyanus side, those numbers were much lower and less diverse. In both rivers, the numbers and diversity of species was less at the downstream site than the upstream site, telling us that water quality was degrading the more char, debris, and ash and material is coming into both systems. Kenneth is out there now. He's continuing that study this year. And he assures me that even in the Guyanus, there are more this year. He had just his couple of days of seeing a greater diversity and a higher number, including those individuals like chironomids and caddisflies and dragonflies that have a lower tolerance for pollution. So that is very happy to hear. We're talking about water supplies, just to contrast these two systems. Over in Pecos, the majority of individuals depend on groundwater. The village of Pecos proper has a well field off to the west of town, shown by this green dot. And over in the village of East Pecos, they have a mutual domestic water consumers group that shares wells. None of these wells was breached by anything related to the fire. But for all of us that know about the groundwater, we know that when there's less infiltration in the headwaters and diminished floodplain recharge in the midwaters, that's undoubtedly going to have an impact, a negative impact on the groundwater table and water usage, well water usage. We worry too a little bit about enteric microorganisms. And last summer, the New Mexico Environment Department had a broad invite for people to have their well water sampled, because especially in times of flood, when the well heads can be submerged, you can worry about E. coli and other microorganisms getting into the water. There weren't any incidences or reports of that. Now let's talk about the Las Vegas side of Guyanus. As we said earlier, the Guyanus River supplies 90% of the drinking water supplies to the town of Las Vegas. It is the primary supply. This is a annotated image that I created off of Google Earth showing portions of the Guyanus River where the city diverts water from the Guyanus. They collect water in a sediment basin, and then they pump it into one of 3 reservoirs: Peterson, the Bradner, and Story Reservoir. We know after all of the fires and all of the breaches of some of the systems, the Army Corps of Engineers was out there working to secure the systems, putting up rock securement blankets, putting up some gabions, those netted rocks to hold back some of the debris, putting in some of those geo rugs, those high tensile steel ring fences to hold back the debris and secure our supplies. But any kind of threat to our water supplies, whether it's droughts when we don't have a lot of water in our systems, or whether it's a disturbance like a forest fire, we've known for a long time. And here's a quote from former Mayor Tony Marquez, that our regional drinking water supply shortages are some of the most immediate threat to Las Vegas's economic stability and quality of life. This is a picture of Story Lake that I took just last Wednesday and looking at the hills around it. So last year I offered some not so new and some new ideas about how to increase the city's drought and fire resiliency. Any municipality that has one major source of water is a town that's in trouble. And so Las Vegas has long known that. And so working on finding ways to increase its surface water supply. How do we reduce system losses? How do we improve reservoir storage and recovery? How do we explore and develop other sources of groundwater? How do we just diversify our water supply portfolio, strengthening conservation and developing wastewater treatment and reuse ways? Well, these next few slides will share how engagement in the environmental geology program is helping with just that. A couple of weeks ago, maybe it was a month ago, City Manager Maria Golvari talked about how, as the city moves forward with using the tremendous amount of monies that have been allotted to recover from the fires, things just don't happen overnight. Whether it's the pre-treatment system out of Story Lake, whether it's building a new water treatment system where the existing plant is, you need professionals who know how to run those systems. You need people who understand water resources science. The Environmental Geology program offers several degrees that do just that. Our Bachelor's of Science degree has specialties in environmental science, water resources, and geology. We offer minors in geology, GIS, and environmental science, and a master's of science in natural science with concentrations in both geology and environmental science and management. So in our degree programs, the courses that the students are taking and the thesis studies in which they embark, they're working to improve the situation. We're also doggedly pursuing different grants for water quality and water quantity research. Brian Mann in the lower left-hand corner there did a study a couple of years ago, creating a hydrologic budget for the city of Santa Fe, the lower Santa Fe River. His data is one of the most solid studies done to date and is being used by Santa Fe today to understand the ins and the outs. And our students are doing things like that in our local water supplies. We're also doing different kind of studies to increase our students' capacity for doing GIS, drones, geospatial studies, and more. And then partnering, strengthening existing partners and building new ones. Here are some pictures of my students working with mentors from the Upper Pecos Watershed Association, learning how to do water and bio surveys on the Upper Pecos River. Some of our students have volunteered for different activities being held by the Hermits Watershed Association, and we're working with the USGS, partnering with the New Mexico Forest and Watershed Restoration Institute, the New Mexico Environment Department, like I said, the city of Santa Fe. And just this last year, I was asked twice to partner with and lead field trips for the Rio Chama Congress. In conference presentations, we're empowering students to energizing and elevating the conversation so that they can inform people about what they are doing and share. And so give them baseline data. There's a group from the USGS that are also doing macroinvertebrate studies in places way up on Porvenir and Guyanus, and to share what Professor Jacoby, Professor Martinez, and their students and our students have been doing over the last 20+ years has been exhilarating. And most recently, Mary Francis is doing some hydrologic modeling to understand the response of the Guyanus watershed to the spring runoff, that snow melt events. There's a lot of data out there, but not a lot of people mining that data and doing the actual deep dive to understand what those hydrographs and what those different numbers are telling us. Preliminarily, the Guyanus watershed looks like it has been resilient to the warming and the snow melt runoff. Whereas the spring hydrographs are usually pretty broad with just peaks that represent some storm events during the summer. That's exactly what it looked like this year, identical to the past. There weren't a lot of storms, there weren't a lot of those fearful big runoff. So I end my presentation with this picture that I took last Wednesday of a sunflower coming up through the burned timbers. It reminds me of our students and reminds me of our communities that have just been so resilient to all of the stressors that they experienced over the last 1+ years. They remain positive and they remain steadfast in their pursuit of new skills to address these threats and new knowledge to inform water scientists, decision makers, and restoration specialists. I thank you guys for your time and also ask for your continued support of the environmental geology programs at Hermits. Thank you.
If there's any questions or comments?
Well, thank you, Dr. Lindline. What type of pollutants can you expect during the wildfire, especially let's say in the New Mexico area?
Okay, so now Benito is asking about what pollutants to expect. There can be natural ones, like I mentioned on the PECO side, the naturally occurring sulfides, or the remobilization of any of those mine wastes or a mine sediments. There could just be any runoff of that charred debris and all that ashy material. It's not necessarily a chemical pollutant, but it, increases that turbidity, lessens the dissolved oxygen, and just impairs a stream. There can be some man-made chemicals that enter into the system, like some of the retardants that were being used to put out the fire. To my knowledge, most of that was diluted, and there haven't been any incidences of impairments to drinking water. But you just do think about, some of the terrible cases where structures burned. You've got those plastics, you've got those petroleum, materials that are entering into the system. So it's something that the New Mexico Environment Department or the Forest Service and others are aware of and monitor.
And do you think there are ways by which you can monitor the heavy metal contaminants that can flow with the?
Absolutely. So now Benita is asking about heavy metals. So the whole reason why Letitia and Megan and I started that study a couple of summers ago, and I was remiss, I didn't shout out to the support from the New Mexico Water Resources Research Institute, was they were undergraduates. They wanted to learn a little bit about water monitoring, but they were taking a class of mine where we were using the PECOS as a case study, because in the summer of 2019, a company, Mexico, had submitted an application for exploratory drilling. And some in the community were concerned about any kind of drilling and down the line, mining, how that might add to chemical loading. So while they were helping each other, Megan was in charge of the physical chemical parameters that you saw there. Letitia and I did collect grab samples from 5 sites over the 4 seasons of that year. And all of the metals that we were studying, from chromium to vanadium and others that were copper, were all below the detection limit to the EPA standard lab that we sent the samples off to. So that's our baseline. If we're wondering if any of those are mobilized, we need some money to do some more water chemistry analysis.
Thank you, Jennifer.
Any other questions?
Well, thank you again, Dr. Lindline. We appreciate you taking the time to talk to us today.
You're very welcome. It's my pleasure.
Good afternoon, everyone. I'm very pleased to introduce Dr. Peter Linder. He teaches a variety of courses in history here at New Mexico Highlands and has been on staff for 27 years. Some of the courses that he currently teaches are history of New Mexico, history of the Southwest, and history of Latin America, which is the foundation for his presentation today, which is called